Good morning, students.
Good morning, ma'am.
Today in this module, we are going to learn about different methods of separation of the components of a mixture. Previously, you have studied about the physical properties of substances. The physical properties of any element can be its density, its hardness, color, solubility, melting point or boiling point, etc. A mixture can be of two types, heterogeneous and homogeneous. Now, if a mixture is heterogeneous, then simple physical methods are used for the separation of the components of a heterogeneous mixture. Now, for example, at home you must have seen that your mother takes out the stones from the rice before it is being cooked. So, this method of separating any substance is known as hand picking. Now, tell me, when you make tea at home, or you must have observed somebody making tea, what is the method of separation which is used during making of tea? Yes, Rosie?
Ma'am, sieving.
Very good. So, we see sieving is the method which is used for making tea, in which sieving separates the tea leaves from the tea. Similarly, the farmers, they use the method of threshing and winnowing to remove the stalks from the wheat grains. Here, the stalks are first beaten in the process of threshing, and then the lighter component is separated from the heavier component by the wind, and this is known as winnowing. Similarly, there are many methods of physical separation, like using magnet to remove the magnetic component of the mixture, etc. Now, let us see, if we want to separate a dye from an ink, what method should we use? Here, let us take a beaker, fill it half with water and place it on a tripod stand. On the mouth of the beaker, we will place a watch glass. In the watch glass, we will place the ink. And now, let us heat this apparatus. On heating, the evaporation will take place, and the water, which is the solvent in the ink, will get evaporated, and we will get the dye in the watch glass. We do not use the direct method of heating for a dye because it will decompose the dye. So, we use the method of evaporation to separate the dye from the ink. Now, let us see how we can separate cream from milk in a test tube and put the test tube in the centrifugation machine. When the centrifugation machine is switched on, this test tube will rotate at a very high speed in the centrifugation machine. And as a result, what will happen is the fat molecules which are present in the milk will come closer to each other, and they will collide with each other, and they will form the cream. This cream will come on the surface of the milk, and when we stop the centrifugation, the cream will be separated from the milk and it will be present on the upper surface of the milk. Now, this method of centrifugation uses the phenomena of centrifugation. This technique which is used here is based on the principle that when a mixture is rotated at a very high speed, the lighter particles, they come on the surface of the liquid, and the denser or the heavier particles are forced to the bottom of the liquid. So, when your mother churns the milk at home, again during churning, the lighter fat particles come together and they separate on the top as the cream. This method of centrifugation to remove the cream from the milk is used in the dairies. So, this method of centrifugation is used in the dairies to remove milk from cream is to make toned milk and double toned milk, which we find in the dairies. Now, we come to the next method of separation, and that is to separate two immiscible liquids from each other. So, what are immiscible liquids? Immiscible liquids are those liquids which do not mix with each other. So, the two liquids which are present at home and are immiscible are oil and water. Now, this method is based on the fact that immiscible liquids do not mix with each other, and if they are allowed to stand, they will form two separate layers. So, let us do an activity to show how it is possible. We will take a separating funnel and attach it to the stand as shown in the figure. Now, we will pour the mixture of kerosene and water into the separating funnel. Now, we will allow the separating funnel to stand for some time. We will see that kerosene and water will form two separate layers. Now, we will open the stopcock and allow the water to slowly come out and collect in the beaker. This will continue till the kerosene layer comes till the stopcock. Then we will close the stopcock and we will get water in the beaker and the kerosene will remain in the separating funnel. So, here we have used a separating funnel to separate two immiscible liquids. Now, the application of this method. This method is used to separate two immiscible liquids. It is also used in the blast furnace while the extraction of iron takes place from its ore. The two layers are formed, the lighter slag on the top and the heavier molten iron at the bottom, and it can be separated by this method. Now, we come to the method of separating two miscible liquids from each other. Miscible liquids mean two liquids that are mixing in each other or are soluble in each other. In this technique, the method used is to convert the liquid into vapor and then condense the vapor back on cooling into liquid. Let us see how we can separate ammonium chloride from a salt. This method we have discussed in the previous module also. So, ammonium chloride has a special quality. So, when ammonium chloride is heated, it directly changes into the vapor or the gaseous state. Let us take an activity to show this. We will take ammonium chloride and salt mixture in the china dish and cover it with an inverted funnel, place it on a tripod and start heating it as shown in the figure. Now, on heating, the ammonium chloride will change into white fumes or it will go into the vapor stage. And this gas on moving upwards will get cooled and will get deposited on the stem of the funnel. So, here ammonium chloride solid is changing into gas and then converting into solid again on cooling. So, in this method, ammonium chloride has been removed from the impurities which are the salt and it is now coming in pure form after it has been heated. So, this method in which a solid on heating directly changes into a gas without changing into the liquid phase is known as sublimation. So, this method of sublimation is used to separate substances which are volatile and which sublime on heating from substances which are not volatile and do not sublime on heating. This method is used to separate substances like camphor, naphthalene, ammonium chloride or anthracene. Now, let us discuss the method we should use to separate two miscible liquids. Here the method that we use is known as simple distillation. In this method, we use two liquids which have different boiling points and there should be a difference between their boiling points. These two liquids will separate out at their boiling points and then we can condense them to form the liquid again. Let us take the example of water and acetone which are miscible liquids. The mixture of water and acetone will be taken in a distillation flask. The distillation flask will be fitted with a thermometer and the apparatus will be set up as shown in the figure. On heating, we will see that the temperature in the thermometer will start rising. At 329 Kelvin, that is the boiling point of acetone, the acetone will start changing into vapor and it will move up and move into the condenser. In the condenser, it will get cooled and change back into liquid acetone which can be collected. Here we will observe that the temperature will remain constant once acetone starts vaporizing, that is at 329 Kelvin, till all the acetone has vaporized. So here we see that acetone has got separated out and the water remains in the distillation flask. Now if we keep heating this again, then the temperature will rise to 373 Kelvin, that is the boiling point of water, and now the water will start vaporizing and again pass through the condensation tube and we can then collect the liquid water which is pure form of water, also known as distilled water. So we see that this is the method to separate two miscible liquids which have different boiling points and can be separated at their boiling points. To separate a mixture of two or more miscible liquids which have boiling point difference less than 25 Kelvin, we use a method which is known as fractional distillation. Now let us explain the method of fractional distillation. Here we will set up the apparatus similar to simple distillation, but in the between the distillation flask and the condenser, the difference will be that there will be a fractionating column between the distillation flask and the condenser. The apparatus will be set up as shown in the diagram. A simple fractionating column has glass beads inside it and these glass beads provide the surface for the gases to repeatedly condense over them. Now we know that air is a homogeneous mixture of gases and the various components of air can be separated by using a fractionating column. Let us see how we can separate the various components of air. Let us see how we can separate the various components of air. The air is first subjected to pressure. Then it is cooled by lowering the temperature. Now under these conditions, the gaseous carbon dioxide will convert into dry ice and can be separated out. Now the rest of the gases of the air will get liquefied. The liquid air is then subjected to fractional distillation. Here the liquid air is allowed to pass through the fractional distillation column where it slowly gets warmed up and the gases get separated according to their boiling points. The gas having the least boiling point will get distilled over first. So nitrogen, which has the least boiling point of minus 196 degrees Celsius, will distill over first, followed by argon, which has a boiling point of minus 186 degrees Celsius, and oxygen, which has the highest boiling point of minus 183 degrees Celsius, will get distilled over in the end. So if we want to separate oxygen from the other gases, then we need to distill over the other components so that we can get oxygen from the air. Now you have studied about the air earlier. So nitrogen is 78.1%, oxygen is 20.9% and argon is 0.9% in the air. So now let us discuss a very interesting method of separation known as chromatography. Chromatography is used to separate the colors of a dye. Here we take a thin strip of filter paper or chromatographic paper. On the lower edge, 3 cm above the lower edge, we will draw a line with a pencil. In the center, we will make a dot with black ink. The black ink should be water soluble, that is either of a sketch pen or fountain pen. Now we will place the chromatographic paper or the filter paper in such a manner in a beaker of water that the water level is just below the ink. Let the ink dry. Now we will place the paper in such a way in a beaker containing water that the level of water remains below the ink. Leave it for some time. Ink has water as the solvent and the dye is soluble in water. Generally, ink contains 2 or more colored dyes. As the water rises up in the filter paper, it carries the particles of dye along with it. The color which is most soluble in water will rise up to a higher level and will form a colored dot at that point. And the other colors will rise to different levels depending upon their solubility in water. As a result, we will get different colored dots on the filter paper. This method is known as chromatography. Chroma in Greek is color. Now this method application is that it is used in the labs to diagnose various diseases, and it is used for urine test and blood test. It is also used to separate colors from the dye and the pigments from natural colors. Another method of separation is crystallization. Now let us see how we can use the method of crystallization to get crystals of copper sulfate from its solution. We will take 5 grams of impure copper sulfate in a china dish. We will dissolve it in minimum amount of water and filter this solution to remove the impurities. Then we will evaporate this solution so that we get a saturated solution of copper sulfate. Cover this china dish with filter paper and leave it undisturbed at room temperature for 1 day. Then we will see that we have obtained crystals of copper sulfate in the china dish. So this method of crystallization is used to obtain a pure solid in the form of its crystals from its solution. Crystallization is better than evaporation because during evaporation some solids decompose and solids like sugar char on heating to dryness. In crystallization, some impurities may remain even after filtration and these will contaminate the solid. Now the uses of crystallization. Crystallization process is used when we obtain salt from seawater. The salt we obtain from seawater contains many impurities and we can get pure crystals of salt by the method of crystallization. We also use this method to get pure alum from its impure sample. So now we have discussed many methods of separation. We can opt for any of the method of separation depending on the nature of the components of a mixture and obtain the pure components of the mixture. Let us now discuss the different methods of purification of water which comes to our houses. First, the water from the reservoir is sent to a sedimentation tank. Here the water is allowed to stand for some time so that the impurities present in the water can settle at the bottom of the tank. Then the water is sent to the loading tank. Some particles are so small and their density is low, so they do not settle at the bottom in the sedimentation tank. So in the loading tank, some alum is added. This alum will load the particles and as a result make it heavier and the particles will settle down. Then the water will be sent into the filtration tank. The filtration tank contains 3 layers. The layer at the bottom of the tank is made up of coarse gravel. The second layer is made up of finer gravel. And the last layer on the top is a thick layer of fine sand. When water passes through this filtration tank, the soluble impurities will remain in the layers. And then the water from here is moved into the chlorination tank. In the chlorination tank, it is mixed with bleaching powder. Bleaching powder will kill the bacteria and the germs in the water. Now the water is fit to be supplied to the various households. So you see, we have discussed various methods of purification and we can use any of these methods to obtain a pure compound. With this we come to an end of this module. I hope you have all enjoyed and learned in this module. Thank you so much, students.
In this module, you have learned that heterogeneous mixtures can be separated by simple physical methods like hand-picking, sieving and filtration. Miscible liquids can be separated by fractional distillation. Distillation is a method of separating substances based on differences in their boiling points. Centrifugation is a process which utilizes the centrifugal force to separate molecules of different densities. Filtration is used to separate solid and liquid mixture, where a strainer or filter paper is used to separate solid particles from liquid particles. Crystallization is a process that separates a pure solid in form of its crystals from a solution. Chromatography is a technique to separate 2 or more solutes dissolved in same solvent. To watch the next video, please attempt the following questions. Question number 1. How can we separate cream from milk? Option A, centrifugation. Option B, filtration. Option C, distillation. And option D, none. Question number 2. How can we separate mixture of salt and ammonium chloride? Option A, centrifugation. Option B, filtration. Option C, distillation. And option D, sublimation. Question number 3. How can we separate a mixture of 2 miscible liquids? Option A, centrifugation. Option B, filtration. Option C, distillation. And option D, none.